Hello everyone, today we have a new video. It's going to talk about trigonometric graphs. So let's see what are trigonometric graphs and then we're going to see some examples. So first of all, we're going to start with the sine. So how can we draw the graph of sine? The graph of sine, we have a range, as you know. It starts from 0 till 180 degrees. This is the first range that we will do here. So if you see, we have a table that includes x and y. When we have x coordinates and y coordinates. So if the angle is 0, first of all, the angle is 0, 30, 60, 90, 120, 150, 180. So here, if you calculate on the calculator, sine 0, sine 1, sorry, sine 30, sine 60, sine 90, sine 120, sine 150, sine 180. So you can draw the graph and you can plot the points in here on the graph as follows. So you're going to find the curve looks like this. This is the first part of the curve from 0 till 180. But most probably you'll be asked in the exam to draw between 0 till 360. So let's see the complete graph, how we draw it from 0 till 360. You need to know 5 main angles. The first angle is angle 0, then angle 90, then angle 180, angle 270, and angle 360. So you need to calculate the first, the 5 main angles first. What's the sine of 0, sine of 90? Sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0 as well. So let's plot the points in here. The first point is 0 and 0, then 90 and 1, then 180 and 0, then 270 and -1, then 360 and 0. Then you can draw the graph. So here is the graph of sine in the range from 0 till 360 degrees. So you need to plot the 5 main angles when you're asked to draw in the range from 0 till 360 degrees. So you need to find what's the sine of 0, 90, 180, 270, 360. If you want to find some angles in between, it's fine, but these are the 5 main angles. And here is the graph, how it looks like. It has one top in the positive side of y-axis and one bottom in the negative side of y-axis. We're going to move to the cosine. How to draw the cosine, the graph of cosine. You can find it first in the range between 0 till 180 degrees, when the angle is included between 0 to 180, the first two quadrants. You need to find what's the cosine of 0, of 30, 60, 90, 120, 150, 180. So you need to calculate them on the calculator. What's the cosine of 0 is 1, cosine of 30 0.87 approximately, and so on. Here we have the positive and the negative sides, the positive and negative parts of y-axis. So we need to plot 0 and 1 first, then 30 and 0.87 and so on. So the graph will be drawn like this. This one it's between 0 till 180. So we're gonna draw another one between 0 till 360 because this is the most probably question repeated in the exams in the updated syllabus. So how to draw it between 0 till 360, we're going to do the same thing which we have done in sine x, which is we're going to plot the 5 main angles, which are 0, 90, and 180, 270 degrees, and 360 degrees. So what's the cosine of 0, cosine of 90, cosine of 180, and so on? Cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is -1, cosine of 270 is 0, cosine of 360 is 1. So let's plot the points, 0 and 1 first. Then cosine 90 is 0, cosine 180 is -1, cosine of 270 is 0, cosine of 360 is 1. So you can match now the points which you have plotted. So now this is the graph how it looks like for the cosine when it's included between 0 till 360 degrees. It looks like here is a part of top and there is a bottom, then another part of the top which is decrease, then decrease, then increase, increase. Now we're going to move to the tan, how you draw the graph of tan. This is the part of the graph between 0 till 180. Actually, the graph of tan is a bit different. We cannot use the 5 main angles because the tan of some angles is undefined, the same as tan 90 is undefined. We cannot find it. Tan 0 is 0, tan 180 is 0, and tan some angles in between. So what should we do this? We need to know how the graph looks like. And actually, this is close to be part of the reciprocal graphs, the asymptotes reciprocal graphs or rational graphs. The asymptote, as you see here, this is the asymptote, the line that approaches but never reaches. The graph here approaches to the x equals 90 but never reaches or never touches this one. So I'm gonna show you now how to draw the tan x between 0 till 360. So here between every time between we'll split between the 180 degrees between the angles. We're going to start from the 90, then 270, then 450, and so on. So if you're going to start, here is a negative part of the graph, but we're going to focus on the positive part today. So it will be here. This is how the graph looks like. We're going to redraw it again. And then here, this is the center point. It comes this positive part, then this negative part, and then here on the 360 we have only the negative part, which is here. So from 0 to 90, this is the part of increasing. Then from 90 to 270, here is a part of increasing and then decreasing. And then we have from the 360, this is the part decreases. What are these? These are asymptotes. Maybe you are required to find, you will be asked in the exam, write the equation of the vertical asymptotes. Here the asymptote x equals 90 degrees. And here this asymptote is x equals 270 degrees. Maybe you will be asked or maybe not. So you need to know what's the asymptote because it's really important. Asymptote is the line that the curve approaches but never reaches or never touches. So it's very close but it does not touch. And the range of y-axis is not 1 and -1, it goes more. So this maybe will go to infinity, it goes up, and here this goes to -infinity. But here in the tan and the sine and cosine, the range is from 1 to -1 only. It cannot be more than 1, it cannot be more than -1. So this is the curve of tan between 0 to 360 degrees. Now we're going to move to how to solve trigonometric equations, but it's really important to know something first, which is called unit circle and the asterisk rule. I'm going to know what's the abbreviation of the asterisk rule, but let's see first. So now we're going to see what's the asterisk rule. Asterisk is an abbreviation for all, sine, tan, cosine, or we can memorize it with all students take chemistry. So we're going to see first what's the unit circle. Here, as you see, this is a circle which has been drawn on the axis coordinate, x-axis and y-axis. And this circle, it has a radius 1. So the radius of this circle is 1. And then what did we do? We have done a y projection from the radius. Y projection goes on the x-axis. And we have here an x projection on the y-axis, so we have formed a right angle triangle. The radius is 1. So what will be the benefit from this one? We're going to see now. How can I find from this one by using SOHCAHTOA? How can I find cosine, sine, and tan of this angle? So let's find the cosine first. Cosine theta. Cosine, it was what? It was adjacent over hypotenuse, so it's x over 1, so it's x. So how to find the cosine theta from the unit circle? It's x, the value of x. How to find the sine theta from the unit circle? It's opposite over hypotenuse, which is y over 1, equals y. So what about the tan? Tan is what? Tan theta is opposite over adjacent, so it's y over x. So now, till now, teacher didn't tell us what's the beneficiary of studying the unit circle. Now let's apply this in the asterisk rule. This triangle here is in the first quadrant. The values of cosine, sine, and tan. Cosine theta is in the positive side of x-axis, sine is in the positive side of y-axis, and the tan is positive as well. So if we're going to move in the second quadrant, if I draw here a triangle, the same one with radius 1, right angle triangle. If we want to find cosine, sine, and tan, to find the cosine, cosine is, this is the angle theta. To find the cosine, cosine is x over 1, and here is y. But x here is in the negative part of x-axis, so it's negative x over 1, so it equals negative x. If you want to find the sine, sine is opposite over hypotenuse, so it's y over 1, which is equals y. And then what about the tan? Tan is opposite over adjacent, so it's y over negative x, which is negative y over x. So in the second quadrant, what do you notice? We notice that the cosine is negative, and the sine is positive, and the tan is negative. So this is the second letter. If you notice here, what's the first letter of the asterisk rule? It's A. All angles are positive in the first quadrant. So the meaning of A is all angles are positive in the first quadrant. As you see here, the cosine, the sine, and tan, their answers are positive, or the results are positive for sine, cosine, and tan in the first quadrant when the angle is between 0 to 90. But if we move to the second quadrant in here, so you're going to find that the cosine of any angle in the second quadrant is negative, and the sine in the second quadrant is positive, and the tan is negative. So the second letter S here refers to the sine only is positive in the second quadrant. If you notice the letter T in here, it will be only tan, which is positive, and the last one, C, which is cosine, is positive. If you follow up in the same way of the unit circle, you're going to reach to that all angles here, all trigonometric ratios are positive in the first quadrant. The second quadrant, only the sine is positive. The third quadrant, the tan is positive. The last quadrant, or the fourth, only we have cosine is positive. So let's see the asterisk rule here. Here is the asterisk rule. Whenever we have the angle is between 0 and 90, all trigonometric ratios are equal. Sorry, all they are positive. So A for all, sine, cosine, and tan, they are positive, the values of sine, cosine, and tan. What about if the angle is between 90 to 180 degrees? If the angle is between 90 to 180 degrees, only the sine is positive. Between the 180 to 270, the third quadrant, the tan is positive. The last from 270 till 360 is cosine is positive. So you need to memorize it as asterisk, or all students take chemistry. So here we have the range between for this one from 0 to 90 degrees. We get the angle theta, here. But from 90 to 180, this is the second quadrant. We have the sine, then tan, then cosine. Let's see how the example comes in the exam. For example, you are required to solve sine x equals 0.5 when x is included between 0 to 180. So what does it mean x is between 0 and 180? It means you are on the first and second quadrants. We need to know what's the angle that has a sine value which is 0.5. So you can do it by using the sine inverse, or the inverse of trigonometric function, trigonometric ratio, by doing sine inverse of 0.5, then you can find the answer, which is 30. But here we can draw the graph. This is the part from 0 to 180. So now 0.5 is the value on y-axis, which is here. So we're going to draw a line on the 0.5 to know where's the intersection points between the curve of sine from 0 to 180, as it's mentioned in the range here. And we need to know the 0.5, which is on y-axis, meets the curve in which points. Actually, we have two intersection points, 30 and 150. Are you required every time to solve the equation to graph this one? No, you're not required to do it. So how can we do it algebraically? As it's mentioned here, you will do sine inverse for this one, for the 0.5. So you got the value of x is 30, but actually it's not the main value. You have one more. So you can draw the asterisk rule. Here 0, then 90, then 180. So you have two solutions in here, one in the first and one in the second. Why one in the first and one in the second? What's the value of sine which is given in the question? The value of sine is positive value. So you must memorize asterisk. The sign is positive in the first and second quadrants. So you are solving in the first and second quadrant. You are trying to find what's the value of x in the first and second quadrant. In the first quadrant, if you do sine inverse of 0.5, you got the angle is 30 degrees, which is here. So what about the second quadrant? How can I know it? You have two ways. You will do what? You will go clockwise 30 degrees from the 180. So you will decrease 30 degrees from the 180 clockwise. So if you remove 30 from 180, it will be 150 degrees. Or you can use the key of each quadrant. The key of the first quadrant is theta as it is. The second quadrant is 180 minus theta. So you can get the value. If you do 180 minus theta, which you got in the first quadrant, you will get 150. So the answers are 30 and 150. One more time, how you find the x in first and second quadrant. In first quadrant, it's very easy. You do sine inverse of 0.5, then you got the angle of 30. What about the second quadrant? You will go to the ending point of the second quadrant, which is 180. Go 30 degrees in the clockwise direction. So here, if you remove 30 from the 180, it will be 150. So the answers of x is 30 and 150. You can make sure by calculating the calculator what's the sine of 30. The sine of 30 is half. The sine of 150 is half as well. Let's see one more example. If I have cosine x equals 0.4 and the angle is included between 0 and 180, what should we do in this case? Now, first of all, I must look at the answer of the cosine. Is it positive or negative? So the first point, I must look at the answer of the cosine or sine or tan. Is it positive or negative? Here it's positive. And what's the range? You are working between the first and second quadrant from 0 to 180 degrees. So you must memorize asterisk rule. Asterisk, all are positive. Sine, cosine, and tan, they are positive in the first quadrant. And then cosine is positive where as well? It's positive in the fourth quadrant. So now, since cosine x is positive, so you are working in the first and fourth quadrant. But here you are required only to find the answer between the first and second. So you need to find one answer only. You can do the cosine inverse of 0.4, then the angle is 66.04. And here is the curve between 0 till 180 degrees. This is how the curve looks like. And then we have 0.4 on the y-axis. So you will draw a line to see what's the intersection point. We have only one intersection point, which is 66.4. So if I want to do it algebraically in the asterisk rule, as I mentioned here, since cosine is positive, it's in the first quadrant and the fourth quadrant, but the range doesn't allow you. The range here allows you only to work in the first and second quadrants. From 0 to 90, then 180, 270, then 360. So here, if you do sine inverse, you're going to find this angle is 66.04. Then the cosine here is negative, the cosine here is negative, and the cosine here is positive. Since it's positive here, so it's positive in the first and last, but the range stops till 180, so you cannot go more. So you have only one answer in this question, which is 60. past paper. For example, if you are required to solve the question tan x equals 2, and x is included between 0 till 360 degrees. So since x is included between 0 and 360, it means you are working in the four quadrants, all of them. So first of all, look at the answer of tan. It's positive, so you must memorize asterisk rule. Here, all, then sine, tan, cosine. So as you see here, tan is positive in the first and third. So how do we do this one? You need to do two things. The first one is you will do tan inverse of the 2. Okay, then you get this. The calculator here. Tan inverse of 2, it will be 63.4 degrees, which is in the first quadrant. 63.4. But here the range allows you to work in four quadrants. So tan is positive where? It's positive in the first and the third as well. So how can you get the other one? So what you will do is, here, what's the limit between the, for the third quadrant is from 180 till 270. You can go clockwise here, or you can go anti-clockwise from the 180, the 63.4 extra. So here we would go more 63.4. So what's the new angle in the third quadrant? The first is 63.4, and the other one will be 180. Then we add the 63.4. The angle will be, just let's calculate this one. It will be 243.4. So for the first quadrant, we just did tan inverse of 2 equals 63.4. In the third quadrant, we added from the 180 63.4 to reach to the other angle. So the limit of the first one is theta as it is, and the second one is 180 minus what you got in the first quadrant. Here is 180 plus what you got in the first quadrant, then 360 minus what you got in the first quadrant. This means how we moved the theta in the four quadrants. So in the first and third, in the first we got 63.4, we keep it as it is. In the third, we just added the theta to 180, so we got 243.4. Let's see one more point. Here, if I have solved 3 times x equals negative 4, and x is included between 0 and 360 degrees. So this time, like you're solving an equation, you need to make tan x as subject of the formula. So tan x will be, we'll divide by 3, it will be negative 4 over 3. In this case, we have the tan is negative. So what should we do? Tan is negative n. If you memorize the asterisk rule, asterisk. So you're going to find tan is positive in the first and third. So I don't need the first and third. I need where it's negative. It's negative in the second and the fourth of negative 4 over 3. You're going to find the angle is negative 53.4. But we did not study how to do the negative angle. So first of all, we'll do something. We have known that the tan is inverse, tan is negative in the second and third. So what we'll do is, you're going to draw the asterisk rule formula here. There's 0, 90, then 180, 270, and then 360. And this part, what we'll do is, here the angle is negative, so this time we'll move the anti-clockwise here. I need to find the answer in the second and fourth. Why second and fourth? Because the tan is already negative. So you will move here 53 degree point 4. So we need to know what's the angle that's remaining in this part from the 0 to here. It will be 306.6. So the first one for the fourth quadrant. And then if you want to find in the second quadrant, this one, so all we'll do is, let's remove this part. So we'll go from the 180, we'll go 53.4. So we need to know what's this angle, the measure of this angle, for this part from the zero. So the measure will be, if you remove 53.4 from the 180, it will be 180 minus 53.4 should be 126.6. So in this part, how you do the negative, first of all, the negative, it's an indicator to know where the angle is located. Actually, it's located in the second and fourth because the tan is positive in the first and third. I don't need it. I need the second and fourth. So here at the fourth, we will go anti-clockwise 53.4 degrees. And here we will go 53.4 degrees from the 180. So we can see another way on the graph. This will be a little bit lengthy. Now it's negative, so the graph of tan was this, from 0 to 360. And here's the 90. And here's the 270. Here's the 180. As we know, here are the asymptotes. Asymptotes here. So the graph was like this. 43, negative 4 over 3, which is negative 1.333. There is the negative 1, here is the negative 1.333. So we can draw a line here to find intersection points. And so you can find the intersection points in here. This is the other way, but the algebraic way is better. So let's see the last example for today. The example is here. On the diagram, sketch the graph of y equals 10x between 0 to 360 degrees, which we just have drawn now. So if you know here from 0 to 90, we go up here. You can make it a bit accurate because this is the asymptote graph. Then we have this one is the lower part, and this one is the upper part. Where it can go like this. And then we have this one here. Then you're required to find 5 tan x equals negative 7. So first of all, we need to make the tan subject like we did in the previous example. So tan x will be negative 7 over 5. So it's negative now. Negative, if you're going to use asterisk rule, you're going to find that tan is positive in the first and third, but I don't need first and third. I need where it's negative, it will be negative in the second and fourth. Second and fourth. So if we draw the asterisk rule, then it ends at 360 degrees. So we need to do what's the tan inverse. This one, x will be negative 54.5. Negative 54.5 is not in the range between 0 to 360. The whole range is positive. So what we will do is, as what we have done in the previous question, we will move 54.4 here in the fourth quadrant. So 360, if we remove 54.5, it will be 305.5 degrees. because this is the fourth quadrant. In the second quadrant, we will move 54.5 up. So it's 180. If we remove 54, it will be 125.5. So these are the two answers in the third and fourth.